So we're doing a little playlist here where we're going through these things here. In the previous video, we saw how computers work. In this video, we're going to look at numeral systems. And so you should really understand how computers work before you jump into numeral systems and measuring bits and text. And so in the next videos, we'll look at measuring bits and text, and then we'll have the palindrome challenge. But numeral systems like binary, decimal, hexadecimal, how do they work? Here it is. So first, we're just going to look here at the decimal numeral system. And let me zoom in on this just a touch. And so you can see there in the decimal numeral system, we have the ones, the tens, the hundreds, the thousands. So if we have a number like 420, what that's really saying is we have like two $10 bills and four $100 bills. And when we have four 100s and two 10s, we have 400 plus 20 plus 0 ones, we've got 420. And so we say how many in each place we're going to have. And the way we get these places is we call this base 10, right? Because you can see there's like a base there, and that base is 10. And we have 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, so on and so forth. And that's how we get these different places. So anything to the power of 0 is 1. And 10 to the power of 1 is 10. And 10 to the power of 2 is 100. And 10 to the power of 3 is 1,000. And so that base 10 decimal numeral system, once you understand this pattern, that you do the base to the 0, to the 1, to the 2, to the 3, you can now do a numeral system with any other base. And so if we did a numeral system with base 2, we just do 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And just like up here with 10, we got the ones place, the tens place, 10 to the power of 2 is the hundreds place, 10 to the power of 3 is the thousands place. Here we get the ones place, but then 2 to the power of 1 is the twos place. And 2 to the power of 2 is the fours place. And 2 to the power of 3 is the eights place. And 2 to the power of 4 is the 16ths place. And likewise, if we want to do hexadecimal, which is base 16, right, we would have 16 to the 0, which is the ones place, and 16 to the 1, which is the 16ths place, and 16 to the 2, which is the 256's place, and 16 to the 3, which is the 4096's place, right? And so first, to work in any numeral system, you're like, what's the base? If it's base 10 or base 2, you then create your places, right? The ones place, the tens place, the hundreds place, the thousands place, or the ones, the twos, the fours, the eights place. And you do that by the base to the 0, base to the 1, base to the 2, base to the 3, base to the 4, base to the 5, base to the 6. That's the first thing for creating a numeral system. In base 10, in decimal, right, we have 10 digits to work with. We have 0 through 9. We have 10 single digits. Each one of those is a single digit. 0 is a single digit, 1's a single digit, 8's a single digit, 9's a single digit. 10, that's no longer a single digit. That's two digits, right? But we have 0 through 9 that we can work with in the decimal numeral system. So we could use 0 through 9 here, and we could say, hey, we have 0 ones, right? Or we have 1 1, or we have 2 1, or we have 8 ones, or we have 9 ones. But then if we say we have 10 ones, we just say, no, we don't do that because we can't put two digits here. We can only put one digit there. So then, because if you're stringing numbers together, that becomes problematic, right? If we had 4, 2, and then like 11 here, we'd read that as 4,211. You can only have one digit here. And so at 9, we stop and we say, okay, let's put 1 in the tens place, right? And that's how we represent 10, is we got 1 in the tens place and 0 over here or whatever. And it's the same thing down here at the binary numeral system. So up here we use 10 digits, which is 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We use 10 digits that are single from 0 to 9. And then in the binary numeral system, we use 2 digits because it's binary. It's 2 digits. We've got 0 and 1. That's it, right? And so we could have a 0 and a 1 here in the ones place, or we could have a 0 and a 1. In any of these places, we could have a 0 and a 1. And so the way we represent numbers in binary is we say, hey, we got 1 8. Just like up here, we said we had 4 hundreds and 2 tens. Here we have 1 8 and we have 1 2. Well, 1 8, if I had one $8 bill and one $2 bill, I got $10 in binary, in decimal, right? I have $10 in decimal, right? But this is how you say it in binary. I've got 1 8 and 1 2, which would be 101. I have 101 dollars. That's how you express it in binary. That's how you'd express in decimal 10, right? To express 10 in decimal, to express that in binary, be 1010, because I have 1 8 and 1 2. So here's like a question for you, like how would I express in binary 2, right? How would I just express 2 in binary? So 2 in binary would be expressed as 1 0. I have 1 2 and I have 0 1s. How would I express 6 in binary? That would be expressed as 1 1 0. I have 1 4, I have 1 2, and I have 0 ones, right? That would be 6. 4 and 2, 6 in decimal, right? Would be expressed in binary as 1, 1, 0. 7 in decimal would be expressed in binary as 1, 1, 1, right? Because I'd have 1, 4, 1, 2, and 1 ones. So that's how you do that one. And then here's hexadecimal. Well, hexadecimal is a little bit of an issue because we need to have single digits in each place. And hexadecimal has a base of 16. So we need 16 different digits to work with. But after we get past 9, we get into 2 digits. And we can't use 2 digits. We can't put a 10 or 11 or a 12 here. So what we do instead is we have A, B, C, D, E, F. And so if you look at these, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Base 16. We have 16 different single characters that we could use to represent places. And so here, if we wanted to represent the number 16, we would say we have 1 16 and 0 ones. If we wanted the number 18, we would say we have 1 16 and 2 ones. If we wanted the number like, I don't know, 30, we would say we have 1 16, and then we need 14 represented here. Well, that'd be 9. This would be 9, right? 9, that would be 9. This would be 10, 11, 12, 13, 14. So 30 would be 1E, right? 1E would be 30 in hexadecimal. And then 38F here, that translates to 38, we have 3 256s, right? So 3, let's do this here. 3 times 256, and we're going to add to that. We've got 8 16s, so we'll do 8 times 16, and then we're going to see we have F1s, and so F1s is 16, right? That's 16. 16 would bring us 1 over there, so that's 15. We've got, yeah, that's 15, because this is 1, and that's the second place. So that would be 15 plus 15 times 1, right? And so that's our thing, 911. 911. And 911 was a license plate I saw on the back of a Porsche 911. And so 38F is how you represent 911. So those are numeral systems, and you now understand why 38F is such a cool number. It's 911. License plate on the back of a Porsche 911. I also know that has significance now because of the thing that happened on September 11th. And then 2A here, that's how you represent 42. So that would be 2 16s, right? That'd be 32. And then A, so A would be 10, right? And so 32 plus 10 is 42. And 42 is that number in programming, which is Douglas Adams' Hitchhiker's Guide to the Galaxy, where they asked a computer to calculate the meaning of life, and it said the answer is 42. And so that's why 2A has significance in programming, or 42 has significance in programming. So that's how we work. That's how numeral systems work: binary, decimal, and hexadecimal. If you like this video, make sure you hit that like button and that subscribe button. I have a new video coming out after this in this playlist where we're going to look at measuring bits, and we're going to see how to measure bits with the Go programming language, and we're going to use bitwise operations to do bit shifting, and we're going to use iota to increment things, and so that will look like this, where we'll get kilobytes, megabytes, gigabytes, and all the rest of that right there. So we're going to see that in the next video. So if you want to check that out, make sure you hit the subscribe button, hit that little bell, so you'll be notified when that video comes out. See you in the next video.